Hello everyone. Good morning. Today we are going to learn about virtual warehouse and compute separation. So a Snowflake virtual warehouse is a cluster of compute resources. It is used to perform the data operations such as querying. You are going to query some data, load the data, and you are going to transform the data. It acts as a processing engine on the top of the data storage layer. So the virtual warehouse is going to act as it is going to process some data. It is going to compute some data on the top of the data storage layer. The warehouse retrieves the data from the storage, performs a computation, and returns the results, all without altering the underlying storage. So what exactly it is doing is the data warehouse is going to retrieve the data from the storage, and it performs a computation with the inside the warehouse, and it is going to return the results. So all these actions are going to take place without altering the underlying storage. So it is independent from the storage layer. It allows multiple warehouses to share the same data without duplications. So this virtual warehouse is going to allow the use of multiple warehouses to share the same data without duplications. So from the storage, I'm going to take the data from processing. After doing the computational processing, I'm going to give back the results back to the warehouse. So the storage layer is going to take care of the storage of this data. So whatever the computations or the processing I'm going to do, it is completely independent of the storage, what I'm going to do with the data warehouse. So it is independent from the computation layer, and the compute layer is completely independent from the storage layer. So it allows multiple warehouses to share the same data from the storage layer without duplication. What are the key characteristics of virtual warehouse? Elastic, isolated, on-demand, and multiple cluster support. What is elastic? It can automatically scale up the warehouse or scale down the warehouse instantly from the size, smaller size to medium size to large to Excel size. Isolated means each warehouse runs independently. So one workload does not slow the another workload of the another warehouse. For example, I have three virtual warehouse. One is extra small, another one is small, another one is medium, another one is large. Let us keep it for 4. So if I'm going to, each warehouse will be running independently. So if I'm going to change the workload in the medium size warehouse, or going to change the workload in the extra large size warehouse, it is not going to disturb the other warehouses which is small and extra small. On demand, they can automatically start whenever required and suspend when idle, saving the cost. So Snowflake has got the automatic suspension and resume properties. So whenever there is a huge workload, it will automatically scale up the warehouse. When there is a very lower workload, it will automatically scale down the warehouse by saving the cost. What is multi-cluster support? It allows multiple concurrent queries, more than one queries running at the same time by adding compute clusters automatically. For example, the warehouse extra small warehouse is handling some 5 queries, small warehouse is handling some 10 queries, and a medium size warehouse is handling some 15 queries. Concurrent queries means whenever the new set of queries is coming to the medium warehouse, let us say 15 plus another 5 queries, the cluster will automatically scale up the warehouse size so that to support the number of queries you are going to compute. So you can pay only for the compute time you can actually use. What is the compute time you are going to use to process the data? For that only you are going to pay. So it improves both the performance and the cost efficiency of the Snowflake. What is the difference between compute and storage? First aspect is purpose. Execute queries and transformations. The compute warehouse is going to execute the queries and do the transformations. Whereas storage is going to store the semi-structured, unstructured, and semi-structured data, structured data. What is scalability? Instant and independent. If there is a shortage of the warehouse size, it is automatically going to scale up that, which is independent of the storage layer. This is automatically scalable. For example, if the storage size for this particular set of semi-structured or structured data, which I am going to get from the AWS S3 buckets or some external source, it is going to automatically scale up the storage size. What is the cost? Pay per second or minute used. So every second, every minute, what is the computation you are going to do? For that only you are going to pay. This is going to pay per terabyte storage. Example, Snowflake warehouse. Here it is cloud object store. Example, S3 bucket, Google Cloud Storage and Azure Blob. So this is about the compute whereas the storage comparison. This separation gives flexibility, scalability and efficiency. Why separate compute from storage? Why should we separate compute from the storage? 4 factors: independent scaling, better concurrency, cost optimization, and performance isolation. First, independent scaling. You can increase the compute power without increasing the storage capacity. For in case, if I have many number of queries to operate or process, I can increase the computation warehouse size. That time, I no need to bother about the increasing the size of the storage. Better concurrency. Multiple users or teams can run queries simultaneously without interference. Multiple users and different developers from different teams can run queries simultaneously in the compute layer without interference with the storage layer. Cost optimization means you can pause or suspend the compute when idle to reduce the cloud bills. For example, I have a set of queries, so I want to perform the operation now. So it automatically resumes the warehouse. Whenever there is no queries, it automatically descale the warehouse. It makes it suspend so that that time the cloud bill we won't be getting that. So when it automatically resumes and when it automatically suspends the warehouse, it is taking care of the control of the warehouse. So or parallelly, it is going to take care of the cost of the operation as well. Performance isolation. Heavy queries won't slow down other workloads. So for example, as I said in the earlier slide, for medium size and extra large warehouse, I'm getting more number of queries. So when I'm going to increase the size of this warehouse, the auto scaling of the warehouse has to be done here. It is not going to affect the small and the medium where I'm not going to have the extra queries. So this leads to the elastic performance, which where compute scales only when needed. Real world example, Snowflake. Storage. Data is stored centrally in the cloud. Of course, cloud means it is a centralized data warehouse. You are going to store the data centralized. Virtual warehouse. WH underscore sales. It is used by the analyst people for sales reporting. So this is the warehouse created for the sales people for sales reporting. WH underscore ETL. It is used by the data engineers for 90 data loads. So this is used by the ETL people for the data loads. So that is why this is called as WH underscore ETL. WH underscore dev. It is used by the developers for testing and model building. Each warehouse operates independently but access the same underlying data. So developers are going to use this warehouse. They are going to access the same data from the storage layer, but they are going to work independently. So the computation is going to happen independently, but they are going to access the data from the same storage. This allows different teams to work in parallel without affecting the actual performance of the data warehouse. Compute separation architecture. Imagine a central cloud storage layer at the bottom that stores all the data. So the cloud storage layer is the bottom layer of the Snowflake data warehouse. It stores all the data. Above it, there are multiple virtual warehouses, each representing compute clusters. So each warehouse is each computer clusters for different workflows, ETL, BI, and analytics. For example, I am going to keep one cluster, that is a virtual warehouse, for ETL, another cluster for BI, business intelligence, another cluster for analytics. Similarly, I can keep each cluster or the virtual warehouse for each performance or each operations. That's why we are going to have the multiple virtual warehouse. Each warehouse connects directly to the shared storage. For example, the ETL going to connect to the shared storage, it is going to access some data. The BI is going to connect to the same shared storage where it is going to access the data which was already accessed by the ETL. In another case, the analytics is a virtual warehouse or the cluster which is going to access this centralized storage which the same data was accessed by ETL and BI. This is the way how the virtual warehouse connects directly to the shared storage. On top, You can have the visualization tools like Power BI, Tableau, or Looker, which query the data through these virtual warehouses. So, these warehouses are going to store the data. That can be the raw data, source data directly, or the processed data, that is a transformed data. So these Power BI, Tableau, or Looker, they are going to take the data from these warehouses. Clear? They are going to take the data from these warehouses for the reporting purpose. This design ensures scalability, isolation, and efficiency across the user and the workloads. Faster the query performance and reduced latency. No resource contention between users or departments. For the user, no need to bother about any resource allocation, or any departments has to bother about the resource allocation. Cost to control using the auto suspend and on-demand compute. Because of this automatical suspension and automatical resume property, we are not going to about the cost, because you are going to pay only for the how much the queries you are going to compute. Pay per use. So the cost control is there. It's all completely based on on-demand compute. Instant scalability. Whenever there is a requirement to increase the warehouse size, you can increase it. Whenever there is a purpose to decrease the warehouse size, you can scale it down. It supports parallel processing for diverse teams. For example, there are 3 to 4 teams. Each are provided with each clusters or virtual warehouse. So, whatever the ETL tool can process their data, parallelly BI can process the data, parallelly data engineer can process the data, parallelly ETL can process the data. So, each computation is not going to interfere with the processing of the other virtual warehouse. That is called parallel processing. This makes it ideal for organization that performs analytics, reportings, and ETL simultaneously. I want to build the ETL model. Parallelly, I want to do the analysis. Parallelly, I want to build the reporting. All are possible in the Snowflake data warehouse. I hope this session seems to be interesting. And if you have any queries, please post your queries in the below link. Or if you have any questions about this content, if you want more content on this topic, please post your queries in the below link. Thank you all.